So now we come to a new category called polysaccharides. And polysaccharides are those carbohydrates which have a large number of monosaccharides units joined together by glycosidic linkages. So the first polysaccharide that we're going to discuss is cellulose. And cellulose, the monomer unit which constitutes cellulose is nothing but beta D glucose. So beta D glucose is our monomer unit. Now beta D glucose is repeated a lot of times to form the polymer that is cellulose, and cellulose occurs exclusively in plants and is the most abundant organic substance in the plant kingdom. So it is found in the cell wall of plants and it's a straight chain polysaccharides composed only of beta D glucose. And how? So let us just see. Suppose we have got 3 beta D glucose over here. Let us just draw them, the beta D glucose structure. So it will look something like this. We'll have an OH over here, an H over here, then we have H, OH, then we have OH and H, and H, OH, and we have CH2OH and H. So this is the structure which will be repeated a number of times. And let us see how the glycosidic linkages are formed over here. Okay, so now if I have, say, these two beta D glucose, so what are we going to do is we're going to be forming bonds between C1 of one glucose unit and C4 of the next glucose unit. Okay, so let us just start numbering them to make it easier for us. So this is the first one, the anomeric, second, the third, and the fourth. Similarly, in the next one, the first, the second, the third, and the fourth. So now, what did I say? We are saying that the first and the fourth carbon of two molecules of beta D glucose are forming bonds, that is the glycosidic linkage. And how are they be forming them is we will lose an OH from one part of it, and we lose an OH from here and an H from here. So we are only left with an O. So let us just draw them and see. So we have lost an OH and we have lost an H. So we are only left with an O, and thus these two are now connected with an O. So we have, so now you can clearly see that we have a glycosidic linkage present over here between C4 and C1 of 2 beta D glucose. Similarly, this particular glycosidic linkage will be seen in the next this one also. So we'll have, let us just see. Okay, so now the OH is lost from here and we get an glycosidic linkage, that is an ester linkage, and we have an H, and the rest of the beta D glucose looks exactly the same. So now if we have to see this, please note that this will continue on for a long chain of networks. So we can just say that the first one over here as well as this fourth one on the last one will also lose their respective OH, and thus now you can see that we will not see anything over here except for an O. So, and ester linkage is what we're getting in the rest of the structure. So now you can see that we have multiple glycosidic linkages, and these glycosidic linkages are the cause of formation of this particular cellulose structure. Okay, so the monomeric unit is of beta D glucose. This is the monomeric unit. Let us just write down. And next, we were concerned about the glycosidic linkage. So the glycosidic linkage is existing between the glycosidic linkage exists between C1 and C4, both of beta D glucose, different beta D glucose. Now, since we were talking about the reducing nature, let us just see if this cellulose is a reducing sugar or not. So, we know that the first carbon in each of the beta D glucose was anomeric. So now we can clearly see that the anomeric carbon is destroyed. Also, if this cellulose structure is to be completed and we'll get the first carbon of 1 beta D glucose, the last unit, in which the terminal unit, the terminal carbon having the anomeric carbon, we'll see that it does not contribute much to the structure. So overall, we'll just say that the anomeric carbon is destroyed. As you can clearly see in these particular glycosidic linkages, that the anomeric carbon is destroyed, and we can just say that therefore cellulose here will act as a non-reducing sugar. So cellulose is nothing but a non-reducing sugar. Why? Because all the anomeric carbon are destroyed and the terminal have no contribution towards the reducing nature. Okay, so we just saw how cellulose structure is made up of with multiple units of beta D glucose and they're joined by glycosidic linkages between C1 of one glucose unit and the C4 of the next glucose unit. And this is a constituent of cell wall of the plant cell. So this is cellulose, the first polysaccharide.